Welcome back, everyone. So the next presenters, two very fine software engineers with a metallurgy background, geology background, Mikita, Lipski, and Haden, Brearton. But before they come up, I want to tell you a bit of a backstory, okay? So I think we're all familiar with this national instrument, 43101, that is used, I guess, to ensure that what is being reported as being under the ground is actually there, and to maybe validate, the presence of mineralization, etc. So these documents are filed by companies that are getting serious about opening new mine. And for us in the innovation space, one of the things that we're trying to do is find the connection between the NI43 and what we do in terms of developing technologies. So what we did is that we commissioned Minebright to do a study, not a study, actually, to create an application, a software that will enable us to be able to identify those opportunities, those synergies between what we're doing to produce innovations and what is inside the 43101s. It's really, really unique what we've done. So without any further ado, I'm going to call upon the team from Minebright to give us a glimpse of what's possible when we can mine the 43101 for the insights that we need on the innovation side. So guys, come on up.
Yeah, thanks for the introduction, Chamurai. So, we estimated in 2023 there were 175,000 pages of NI43 released, right? And I can almost guarantee that no one has read all those pages. So the project was, can we ask and answer very specific questions from these reports? And the first question that we got commissioned to ask and answer was, how do we help the Mikita members commercialize? You've already done all the hard work. You've developed your technology. If you are treating selenium contamination, there's 2,500 listed companies on the TSX who do mining, but I guarantee that not all 2,500 care about your selenium project. So which ones do? And that's the question that we answered. I'm just going to jump through these. So this is Mikita, great organization, they're growing. This is you guys. You're at some point along your journey. And one thing, I noticed that a lot of you, some of you have clients, some of you don't. So you're at the commercialization stage, you're asking for some money. In some cases, it's a lot of money, and you're asking companies to take a risk. So how do you identify these companies that are willing to do that? And I said 2,500 mining companies, but not all mining companies look the same. That's Grasberg, massive mine in Indonesia, and then we have Gold Rush, Alaska. These guys don't have the same challenges. It's not the same environment. They don't care about the same things. So really understanding who your ideal client is will help you with your business development. And you really need to get this right, because mining, although in terms of GDP, it's quite large, in terms of companies, it's really small. So this is from the government of Canada. There's about 150,000 incorporated construction companies in Canada, and there's 2,500 mining companies listed on the TSX. And most of those have a market cap of sub 30 million. And so they're not even in a position to take a chance on your tech, because they don't, they're keeping the lights on. So this means that you're trying to focus your sales efforts at these very few companies. You need a very targeted message, because you don't have the opportunity to have a shitty closing rate. You need to have a very targeted message to a few number of companies about why your technology is the best. And finding these opportunities is very difficult, You guys are PhDs, you're this and that, you're in the lab, you've developed the technology. Do you have the time to sift through all these technical reports, all these press releases, to determine which projects and which companies are interested in adopting your technology? So this is where our platform comes in, and Mikita's going to give a demo in a few minutes. But basically, we've done the hard work for you. So we've loaded all the technical reports from 2008 through to the present, minus a few weeks, and we've used large language models to read them. And hallucinations, so we've incorporated a human validation aspect to this. So all data points are validated by us. But we just use large language models to generate that first pass, and that's 90% of the time. And then for the most part, it's just us saying, yep, that's true, that's true, that's true. And so that's how we're able to generate so many insights so quickly with a smaller workforce, because we're not reading these reports ourselves. We're just reading the quotes that the large language models used to generate these insights. So the question was, which companies are facing which risks? And so we've created 10 categories of risks based on the MICA members, and we've identified over 5,000 instances of these risks just from 2024 projects alone. So that means that there's 5,000 instances of companies potentially requiring your technology. And yeah, this is how we do it basically. This is slide just supposed to show that we're smart, we're switched on, and the green box means that you should trust us because our eyeballs have been on the data as well. So looking through the member list, we decided to pick on PMAP. So they seem to be an environmental company. I'm not sure they're here or not, and they're championing a new technology for treating acid rock drainage. So for our little internal demo, we just said, okay, did Chamurai waste all his money on our project? So we looked at acid rock drainage in 2024, and we identified over 100 projects that listed it either explicitly or implicitly as a risk using our technology. So that's then a potential 100 leads that PMAP could go to, start annoying them, and seeing if they're interested in their technology. And so this is just the start. So risk and opportunity, that's where we're at. We're also doing the same work on press releases. So we're extracting drill results from the press releases. We have a client that wants to update their leapfrog models and all their neighbors. And so we've created a pipeline where they can do so. And also detailed costs and operating parameters. If somebody releases a technical report and they're saying, oh, we think we can mill at 16 kilowatt hours per ton, but everyone else in the region says, no, it's probably actually 25 based on the technical reports, then you have the opportunity to say, as an investor, that's probably not true. We should update your power cost assumptions. But yeah, so this is just basically the start. And our vision is to become the leaders in mineral intelligence. And so I'm going to kick off and give the platform to Mikita, and he's going to show what the platform actually looks like.
Welcome to our platform. We very honestly called it Mine AI. Basically, this is the landing page where any user of this application would land. As you can see on the top, you would see the latest reports that we pulled out of Cedar. The date effective does not really they're all sorted by the date they were been uploaded to Cedar itself. You would see the company that has prepared the report and so on, so you can quickly assess what's happening there. In the bottom, you would see the companies and the projects that you already investigated and you're interested in, you're following. So as NI43 101 reports coming, there's amendments to them, there's press releases. We're following them. You would get notifications. You would see what's happening and what new insights that we have extracted from them. So Mine AI itself is a database of extracted information from 43 101s. We've currently identified a couple sections. So as Haden mentioned, we've got the companies, TSX, ASX, and some other companies, sometimes private, that have parent companies. We identify mining companies and also consultant companies that help write those press releases and NI43 101s. Sometimes it's small independent companies, sometimes it's big companies like SRK. The qualified people that actually happen to write those NI43 101s, we extract them, their designations, their positions. Sometimes they change, sometimes they don't, but you want to keep the information on who actually wrote which report, so we have the history of that. And of course, the projects that have been connected with the extracted from each 43 101s. And as new, not press releases, 43 101s come in, the stage of the project and their mine type will be updated. Sometimes it's too early to know if it's an open pit underground. You would just know that it's basically we identify if it's too early, and as time goes on, we'll be able to update this information. But as a Mica member, you would want to know your potential leads, your customers. So we've selected the risk, which we extract from 43101s. As Haden mentioned, some of them are inferred, some of them are explicitly mentioned by the qualified persons. And if we take an example of a PMAP, you would probably want to search through the list of 10 designated risks that we have identified, the first one being acid rock drainage. So currently we have 10 types of risk, but as more people and more companies start using it, we'll be able to develop more finite, more targeted risks. So there's a bunch of companies, a bunch of risks that have been identified from different reports. The reports can be downloaded, investigated. Explanation of why each risk has been created is mentioned. But for example, we want to get the company that is in production stage. So we would go and identify somebody like Orezone that has production in Burkina Faso, where Haden and I just came from. We would go and see that they have a Bombora project, and from that information, would want to go and investigate the risks that the system has given to us. I'm going to go quickly. Something quickly. So basically, we wanted to show you that the risk that we identify, it could be acid rock drainage, it could be all of them. Some of them are inferred, some of them are not. We get from the report itself. So currently, it's the latest report. Each risk, so we have identified acid rock drainage. In the report, it explicitly lists in the section risk analysis with the quote given that the main environmental risks associated with this project is acid rock drainage. So for you, you know immediately that it's potentially your client. As you go further, you can start seeing the patterns that there's multiple risks with this because it probably explicitly has been mentioned in a couple sections, including ground contamination and so on. So as I mentioned earlier, this information, we do generate it through large language models, but we do need to validate it somehow. So we've also developed a model for a team of validators to go through this information. And as an example, I just wanted to show you one of the later reports, how the validators go through it. So they AI generates the information. They've got the snippets of information that are just extracted from the actual report, and the people, the validators, aka us, can go through it and ensure that all the information is correct, validate it, improve the information, add the new fields if needed, highlight whatever we find as the quote, and that will be passed to you as the final user. And so finally, as the Mica member, you would be interested in following this project and seeing how it develops over time. So yeah, that's like a little short demo of the project right now.
Okay, folks, if you have if anybody has any questions, feel free to ask. But please grab the mic so that we can hear your question loud, nice and loud. Thank you. We've got about 5 minutes for Q&A before we go to the next session. Okay, so just fill the questions. Yes. Okay, thanks.
One comment while we're fetching the mic. The qualified persons, to me, is also like a really important aspect of this. Understanding who the most important QPs are in the industry, and then we don't have it here, but like filtering by commodity, by geography. If you're developing or trying to target, like South American copper or something like that, you can very easily see like, okay, George Clooney is the most common technical author for the metallurgy sections for that type of project. And then eventually correlating that with actuals, and you can say, but he does a shit job, like his grade reconciles poorly. So that's kind of where we're also heading.
Yeah, okay, thank you very much for the presentation. I have met these gentlemen before, just a casual social event, and this is the first time I've seen the product. I'm a QP, and I specialize in these 43101 type reports. So I'm just very interested in the metadata that you select for sort of summarizing. Is that still a work in progress? Is that something that you continue to develop? Because I think ultimately as a QA tool, we might be able to dig down, and as you mentioned, who are the firms, who are the reputable, more reputable, less reputable, more trustworthy data, those that are perhaps telling a little bit more of the truth, and those that are painting a somewhat rosier picture. So is that one of your, I guess, goals, is to pull that into the metadata and track that?
Yeah, absolutely. So this was kind of the first step of the project, and this was meant more as like a BD tool. But we have all the QP information, and one of our next steps is gathering cost assumptions, like MET test work, even the QA/QC on the drilling databases. So we want to be at a stage, and we think later this year, early next year. You can say, Brian, okay, this project came out. They said 16 kilowatt hour per ton for milling costs, but their neighbor has been operating for 5 years, and they put 22 for their expansion project. So can you justify that 16? And then also with the reconciliation aspect in terms of like the mineral resource, yeah, absolutely. So that involves connecting with like annual reports and other sources of data, which we've already half done with the press releases. But being able to say like, okay, the mineral resource estimate came out at 1.5 grams per ton, but they've been operating at 1.2 the last few years. Like something happened. So yeah, we're absolutely looking into that.
I have a question. So I can see the value of mine data informations and save time and identify right opportunities. But as you mentioned, you need to validate. I've had some experience in industrial database with 70% in average of accurate information. So 1 out of 3, 1 out of 4, you always had in your mind if this accurate, if the phone number is right, or is the right person, etc., etc. So you mentioned that you validate. So by the time you have a report and the time that you validate, so this is someone that will spend time. If you have multiple clients, so how does that work to have that? Is it 2 hours per request, or is it half a day per request? So this is not clear in my mind.
Yeah, so by the time the product goes live, which should be in a few weeks, we'll have all the reports in the system will be validated. And there's roughly 2 reports that are released a day. So and because of the way the system is set up, the AI runs automatically. So, we wake up in the morning, or whoever wakes up in the morning, and there's an alert. You have unvalidated data in the system. On the user side of things, that data is already in the database, but it's flagged as unvalidated. And then we go in and we manually check each data point. Just originally we wanted the large language model to generate everything, but very quickly you realize that hallucinations are too prevalent. So we're around 90-95% accuracy on the large language model, which is pretty good, but it's obviously not good enough. So now it's just become an exercise of speeding up the data collection and validation, where 95% of the data coming in is correctly modeled, and then we just click one button saying, yeah, that's right, instead of having to read the whole report. So we find validation to be pretty quick.
Thank you.
Thank you, Minebright. I can already see how, as a business development tool for a lot of these solutions looking for customers, how that could be a very valuable tool for them to use.